Hi, this is Hiren. I'm here live at SC21 in St. Louis, and I've got here with me Erich Hanke, Senior Principal Engineer from IntelliProp, and he's going to walk us through a demo that he's got here at the CXL booth.
All right, thanks, Hiren. So what we have shown here today is a Intel Sapphire Rapids PDK, a 4U server. We have a CXL connection into an FPGA card that we're running in the backside. In the back of this server, you can see two optical cables, QSFP connections. What we're doing here is a CXL Fabric Adapter, and we can showcase the ability to do load store accesses from the CXL host node all the way over 30 meters away to fabric attached memory components going through multiple levels of switches. On this node, we're running a couple different pieces of software. We have a fabric management software running in this terminal here. We have a Linux local management service running over here. And this is showcasing the status of the fabric. So you can see memory components, fabric switches, a few other memory components, and then their link statuses as well. So another thing that we're able to do with this fabric management software is dynamically add or allocate resources from the fabric to this host node. This is just running a graphical representation of the topology where we have allocated a 64 gigabyte chunk of memory to this host node. So this host node can interact with that memory device in three different ways, either as a block driver or a DAC driver, or as a separate NUMA node with zero associated CPUs. With the block driver, you can use off-the-shelf standard block access tools. DAC driver, same sort of DMDK type tool suite you can use. And if we represent as a NUMA node, you can use this fabric attached memory as malleable memory, just like any other memory in the system. So we're pretty excited to show these capabilities and the long-reach connection from CXL into our fabric solution. So, Hiren, do you have any questions on what we're doing?
Yeah. How many memory modules can you have connected to this fabric?
Well, this particular fabric that we're showing here today is a smaller configuration just because of space and things like that. We have 48 total nodes that are connected to this fabric. The fabric itself can support 4,000 components in one subnet, and we can have multiple subnets. Total capacity, total number of components in the millions. So we think we can cover most use cases from a capacity perspective.
And where's this technology today? Are you guys still in development, showing it? Can I go off to somewhere and buy this today?
We have all of these components built in FPGAs today. The fabric management software is a prototype software running on these prototype hardware components, but we're working on transitioning these FPGAs into hardened silicon.
What is the latency right now you can achieve?
In FPGA, it's a great prototyping tool, but it's not very latency optimized. We're seeing about 800 nanoseconds load to use going across the fabric today. And we think it'll be about a quarter of that as we transition from FPGAs into ASIC silicon devices.
So we're talking 200 nanoseconds, long distance.
Well, we're showing a 30-meter optical cable here. So we can't beat the speed of light just yet. So 30 meters away, that's adding about 300 nanoseconds. So it really supports pod scale and very large total solutions. But the further away you are from that memory, it will add a bit of latency.
I want to play around with some of this, or some people want to play around with this. What do I tell them? Can they come to you and get some of this? Can they build their own? What can they do?
Well, IntelliProp licenses IP, but we also have these FPGA units as demoable bit streams. So if you have some of the off-the-shelf reference FPGAs, you can run our bit streams, run this in your own lab. We're also starting to open up some remote access in our lab that you can log in and start to play around with the components, just depending on what sort of use cases and sizes you're trying to target.
Where do you see the Fabric Manager software? You said it was prototype. Where do you see that going? Have you been working with other partners?
Yeah, so we have, again, multiple booths engaged in this demonstration. One of them is SNIA and the OFA and the Open Standards Pavilion. We've been working in OFA on an open fabric management framework where we can connect the OFMF services to our fabric manager. So we're really excited about that collaboration and excited about the capability of running a generic fabric manager framework that will then have agents for fabric-specific interfaces to those frameworks. So we're looking for a set of different clients that can connect to that framework and then drive requests into our fabric manager to do things like dynamic allocation of resources and reallocation of those resources when a particular job is done.
Show me some applications. What can I do with it?
You can do anything. So the applications, just see this as memory. Any in-memory databases are use cases that we're targeting here, but it's not limited to just memory. Different fabric attachments for accelerators, GPUs, computational memory type devices could be placed on the fabric. What we're showing today is primarily memory focused, but it's not limited to memory.
Okay, so I can have GPUs on here that can then access the same memory like a host node?
Right, so inside of the Fabric Adapter, we have a physical address to fabric address translation. We have an expectation of having a similar endpoint adapter that would then be able to connect to your GPU. So the GPU could see just a very large set of memory. The other nice thing about the Fabric implementation of the multi-GPU is they can go GPU to GPU sharing of the same memory pool. So you can have a self-hosted GPU running a specific application on a common set of memory.
Thank you for your time, Eric.
Thanks, sir. It's been great.